Touch remains an underserved sense for direct manipulation of digital content. Displays that change shape have the potential to bridge that gap. Shape-changing displays need to balance rigidity of their skeleton with the ability to change into a variety of shapes. This sometimes leads to devices with very large numbers of actuators. Here we present a mechatronic shape display based on auxetic materials. We can reduce the number of actuators necessary to present curved shapes by using that auxetic material to interpolate between actuated points. We explored a number of types of material. We start with a planar slab that is cut with a pattern that gives it the ability to bend in two directions. This slab is then given a skin of flexible material that smooths out the small rigid features of the original slab. Different combinations of slab materials, skin material and material thicknesses balance between rigidity and smoothness. We attach the auxetic material to an array of actuators to create a mechatronic system that can display both the displacement and normal of surfaces. Finally, we demonstrate that if the surface is moved, it can smoothly interpolate and present patches of a larger, more complex surface.